video, we'll be learning about the properties of logarithms. Once we know the properties of logs, we'll be easily able to compute equations of different types of logs, and we'll actually be able to get the answers. So let's start off with something basic. Let log x to the base a is equal to m. I'm doing this so that we are able to derive the formula. I don't want you to really remember it or cram it, but I actually want you to understand it. So let log x to the base a be m, and let log y to the base a be equal to n. Notice that my a's are same for both logs. X and y are different, m and n are different. From this we can say that x is equal to a power m. I have moved the a to the other side of the equation. M is already on the other side of the equation, so that becomes the power, and my a is the base. And because this log doesn't have any base, after I move it to the other side of the equation, it goes. So x is equal to a power m. Same applies for this. Y is equal to a to the power of n. I've moved a to the other side of the equation, therefore giving me y is equal to a to the power of n. Now suppose if I multiply x and y, x times y is equal to xy. This is the same as a to the power of m times a to the power of n. By laws of indices, we learned that this if the bases are the same, which is a, and if you multiply them, then the answer is going to be a to the power of m plus n. This we learnt it in the laws of indices or exponents. So if you're not familiar with that, you can look at it in our previous videos. So a to the power of m times a to the power of n is equal to a to the power of m plus n. Now log, okay, let me do it this way, xy is equal to a to the power of m plus n. I want to express this in log form. How do I do this? So if I have something like log of a, log xy to the base a, I will get this as equal to m plus n. So basically what I did was, because this was the power, you can look this up in the previous video so it's clearer for you. Because this is the power, I leave it on one side of the equation. This is the base of the power, so this becomes the base of the logarithm, and this is just left the way how it is. So therefore I've expressed it in log form. So this is equal to this. Now from here we can also say that log a xy is equal to, because it's equal to m plus n, and from here we said that let log x base a is equal to m, and let log y base a is equal to n. So this is the same as log x base a plus log y base a. This is a formula you need to remember. So this is one of the properties of logarithms, and the derivation is here. So it's best if you understand the derivation so that you really won't have to cram it. So basically I've just substituted some values, and from there I was able to get this. Now let's do the same thing. Let log x base a is equal to m, and log y base a is equal to n. I've just copied this. So now from here we can do a very similar thing of saying that x is equal to a power m and y is equal to a to the power of n. It's the same thing. So here what we'll do is that we will divide stuff. Previously we actually did x times y, but now here we'll do x divided by y. X divided by y is equal to x over y, and because x is a power m and y is a power n, we'll do the same thing. So this is a to the power of m divided by a to the power of n. By laws of exponents, we know that this is equal to a to the power of m minus n. I want to express this in log form. How do I do that? I have the power that's left alone, so therefore I have m minus n on one side, and then I'll have log a log x divided by y to the base of a. So from this I know that x over y is equal to a to the power of m minus n. So this is equal to this. So from there my log form becomes this. So again I'll be substituting. So because I know that my m is equal to this and n is equal to this, let me go ahead and substitute again. So log a log xy base a is equal to m minus n, and m is this, n is this. So this is log x base a minus log y base a. This is a second rule which you should remember whenever dealing with logs. Suppose if I have something like log 2 to the power of 3 base 5. This 2 to the power of 3 is the thing that's just staying on its own. The 5 is the base. How will I do this? First of all, let me express 2 to the power of 3 in terms of 2. So this is the same as log 2 times 2 times 2 to the base of 5. Now, we previously learned a rule of logs. If you have something like this, log xy to the base a, it's actually log x base a plus log y base a. So this is actually the same as log 2 base 5 plus log 2 base 5 plus log 2 base 5. Why am I doing this? Because I'm just following this formula. So this is 2 times 2 times 2, so this is like x times y times z times stuff like that, but I'm just splitting them up into the plus forms. So from this we are able to see that this is actually 3 log 2 base 5. This is how it actually looks like. So log 2 cubed base 5 is 3 log 2 base 5. From this we are able to generate a rule. We are able to generate a formula. So we have log of a and x power n. So log x to the power of n base a is actually equal to n log x base a. This is one thing which you should also remember, and the derivation was just done above. In case if you're confused, you can have a look at our previous videos on exponents and changing stuff to log form, just so that it becomes clearer for you. So this is another rule which you need to remember. Any number to the power of 0 is equal to 1. 5 to the power of 0 is equal to 1. I want to express this in terms of log form. How will I do this? So I have the power, I will leave that alone on one side. So I'll have 0 is equal to, this is the base of the exponent, the base of the exponent, so this becomes the base of the log. And then I have my 1 here, so I just leave it the way how it is. So log 1 base 5 is equal to 0. This can be applied to anything. So if I had something like 6 to the power of 0, which is equal to 1, I'll have log 1 base 6 is equal to 0. So basically this number can be anything, and this will still be 1. If this is 1, then the log of 1 is always going to be equal to 0. So from this we can get a formula. Log 1 base a is always going to be equal to 0, where a can be anything. A can be 1, 2, 50, 90, 100, it can be anything. But log 1 base a will always be equal to 0, because any number to the power of 0 is equal to 1. I've just converted this into log form to generate this rule. One more thing, what is a number to the power of 1? A number to the power of 1 is equal to the number itself. So something like 5 to the power of 1, I'll get 5. 500 to the power of 1 is equal to 500. So I want to express this in log form. How will I do this? I have the power which is 1, so I leave that on one side of the equation. I have the base of this power, so I put that as the base of the log, and this just remains the way how it is. Log 5 to the base of 5 is equal to 1. Let's do this with number 30. 30 to the power of 1 is equal to 30. I want to convert this into log form. I have the power as 1, so I leave it on one side. I have the base of the power, that becomes the base of the log, and then I have my other value of 30. So log 30 base 30 is equal to 1. We start to notice something here. If these two things are the same, then your answer will always be equal to 1. Therefore, another rule can be generated. Log a base a will always be equal to 1, because a to the power of 1 is equal to a. That's why log a base a is equal to 1. So this is another rule which you need to remember. Now I think that this will be the last rule you will need to remember for logs whenever dealing with these types of equations. Suppose if I have something like log 1 over 5 to the base 2. How will I solve this? So this is very simple to do. It actually looks a bit complicated, but it's actually very simple. So previously we learned a rule about logs. We learned that if you have log x over y to the base a, you actually get log x base a minus log y base a. We can apply the same in this. This is the same as log 1 base 2 minus log 5 base 2. I've just translated this formula to get this thing. So this is my x, this is my y, and this is my a. So I've just translated this formula to get this. We also learned that log 1 to the base anything is actually going to be equal to 0. So this is actually going to be equal to 0. This, we can't really find a value of that unless you use a calculator. So this I can leave it the way how it is. Therefore, log 1 over 5 base 2 is actually equal to log 5 base 2. We can write a formula out of this. If you have log of 1 over x base a, your answer is actually going to be minus log x base a. This is another formula which I feel that you need to remember. So log 1 over x base a is equal to minus log x base a. So this works with any type of number, and if you know these formulas, then I feel solving log equations will become very easy, and they'll actually be something fun to do.